if 2 points of the plane A with coordinates x1, y1, and are given B point with coordinate x2, y2, then the vector AB has the following coordinates: x2 minus x1, y2 minus y1. And if we have free coordinate of 2 points in the space, since it's a space, then we are going to have x1, y1, z1, and 3D dimension, yes, and B, x2, y2, z2. Then the vector AB in the space is going to be equal coordinate x2 minus x1, y2 minus y1, z2 minus z1. Okay, let me clean this equal sign because it's a coordinate. Just put it here. So from here we can say that to find the vector based on coordinates, given coordinates, then what you have to do from the coordinates of the end of the vector, you need to subtract the corresponding coordinate of the beginning of the vector. So coordinates of the end minus coordinate of the beginning. Okay? So let's do examples. Example 1. We have point A on the plane. Since it's on the plane, we are going to deal with 2D dimension. But if it's in the space, we are dealing with 3D dimension, right? 2, 1 coordinates. And point B has -2 and 3 coordinates. Then to find the vector AB coordinates, what we are going to do, -2 minus 2, because this is going to be our x1, y1, this is x2, y2, and we need to do x2 minus x1, y2 minus y1, so -2 minus 2, and 3 minus 1, which is equal vector AB, -4 and 2. Or we can write down as vector AB negative is equal -2 times I plus 3 minus 1 is J. I will recommend to look at the previous video to see what I and J represent. Okay, so this is another way to write down vector. Okay, the coordinate of a vector are its expansion in terms of basis I and J. In this case, AB is going to be equal in the format of I and G. We are getting -4I plus 2J. Okay, now how to find the length of a line segment or the length of vector? So the length of vector AB, which is we call magnitude, is equal square root x2 minus x1 squared. Remember, we learned that, right? At the beginning, when we started vectors, we will we talked about that the length of vector, remember, the length of vector v, let's say, is equal x squared plus y squared, right? Because we are dealing with coordinates, then the x2 minus x1 squared plus y2 minus y1 squared. And if our vector is in the space, then we will add also z2 minus z1 squared. Okay, let's do example. How to find the length. Let me see. This could be red color because it's a formula. Ooh, too thick. Okay. So, points A with coordinate negative 3, 5, and point B with coordinate 1 and negative 3. We need to find the length of vector AB, magnitude otherwise. So, the magnitude of AB is equal 1 minus negative 3 squared plus negative 3 minus 5 squared, right? x2 minus x1, y2 minus y1. And this is equal square root 4 squared plus negative 8 squared. And we are getting square root 16 plus 64. And we are getting 4 square root 5 from here. Because this is, we are getting 80, square root of 80. And divide it by how much? Let's say by 16, right? It's going to be, here going to be a square root of 16. Here it's going to be square root 5, right? Square root of 16 is 4, and square root 5 gets stuck underneath. Okay? Next example, let's figure it out. Example 3. What do we have? We have point A with coordinate negative 4 and 5, and point B with coordinate 1 and negative 3. We need to find vector AB and vector BA. Okay, B, let's find that we have point A with coordinate 2 and 0, coordinate B, point P with coordinate negative 7 and 1, and coordinate C, and point C with coordinate 4 and 1. We need to find vectors AB, AC, and BC. C case, we have at the point F with coordinate negative 2, negative 1, and 0. This is in 3D dimension in the space. And we have point E with coordinate 0, negative 1, negative 2. So we need to find vectors F, E, and EF. And lastly, we have points A with coordinate 10, 5, negative 4, coordinate, this is A1, coordinate A2, okay, with negative 8, 6 and 3, and coordinate A3, point A3 with coordinate 1, 1, negative 1. So we need to find A1, A2. We need to find A1, A3. And we need to find A1, A4. We have the fourth one also. So let me add here A4, which coordinates are A0, 0, 1. So let's solve it. Case A. So for vector AB, that's mean A is the beginning, B at the point B is the end, and we need to subtract, take coordinate of the end minus coordinate of the beginning, right? So coordinate B minus coordinate A, and AB we are getting 1 minus negative 4, comma, negative 3 minus 5, and we get vector AB is with coordinates 5 and negative 8. Okay, now BA, let me write down here. Now let's find out vector BA, which means B is going to be beginning, A is going to be the end. So coordinate of A minus coordinate of B, right? It's going to be negative 4 minus 1.5, minus 1, I'm sorry, wait for, from I got 1.5, minus 1, comma, 5 minus negative 3, right? And we are getting coordinate of BA, it's going to be negative 5 and 8. Okay, next one, case B, we are going to find 3 coordinates. So it's going to be AB, which going to find out negative 7 minus 2, 1 minus 0. And we get AB, negative 9 and 1. Next, we need to find AC. So coordinates of C, 4 minus 2 and 1 minus 0. And we are getting AC with coordinates 2, 1. And lastly, BC, it's going to be 4 minus negative 7 and 1 minus 1. So we are getting BC with coordinates 11 and 0. Moving to solve C. Okay. Oof. C, let me write down here so we can see these coordinates for C. So FE we are taking coordinate 0, negative 1 and negative 2, coordinate of E, and minus coordinate of F, right? Negative 2, negative 1, and 0. So it's going to be 0 minus negative 2, negative 1 minus negative 1, and negative 2 minus 0. So we are getting FE vector with coordinate 2, 0, and 2. Okay. Next we are doing EF. This is going to be now coordinate F minus coordinate of E, right? Negative 2 minus 0, negative 1 minus negative 1, and 0 minus negative 2. And we are getting vector EF with coordinate negative 2, 0, and 2. Okay. And lastly, the D, we are going to do with 4 points vector. Let me see if I can squeeze in here so we can see the vector. Okay. Okay, A, B, C, and we have to do D. So, A1, A2 is equal negative 8 minus 10, 6 minus 5, and 3 minus negative 4. So this is equal vector A1, A2 with coordinate negative 18, 1, and 7. Okay, next A1, A3. So we have 1 minus 10, 1 minus 5, negative 1 minus negative 4, which is equal vector A1, A3 with coordinate negative 10, no, I'm sorry, negative 9, negative 4, 3. And lastly, A1, A4. So we have 0 minus 10, 0 minus 5, 1 minus negative 4, which is equal vector A1, A4 with coordinates negative 10, negative 5, and 5. Okay, let me highlight on these cases A, B, C, D. And I would like to calculate, let's say, the magnitude, the length of the vector. Let's say for case D, for example, the length of A1, A2. Let's say our vector A1, A2 is equal, okay, without equal coordinates, negative 18, 1, and 7, for example. Yes? Okay. So, what we have to do, to find the length, we are doing absolute value A1, A2, which is going to be magnitude. So it's going to be equal negative 18 squared plus 1 squared plus 7 squared, which will be equal negative 18 squared. Let me see, 18 times 18, it's going to be 324 plus 1 and plus 49. And we are getting plus 1, 325, and plus 49, we are getting 374.